Okay, so this video is talking about saving your metadata and finalizing your georeferencing in this example for Chapter 1 of the Advanced GIS Applied textbook. So here we have the little postage stamp of this Utah aerial photograph from 1958 in Orem near the area of Utah Valley University. And I've managed to place 14 different control points across the image, fairly well spaced out. Control points are shown here. Most of them are at the intersection of the road grids that exist here in Utah. And so anyways, those 14 points are here. It shows the source positions and where they lie on the map coordinates in this NAD 83 UTM zone 12. And then it shows how close they were basically able to model the position using a second order polynomial solution to kind of maximize the fit to each point while warping the image in a second order polynomial way. And so actually it's only 12 control points because I had to delete 2, which were not very well placed initially, including the very first point. That's often the case. The first control point you'll use is kind of just to get the image into the base map area from the origin of the coordinate system. And so that's a good one to candidate to kind of redo after the fact. But with 12 coordinates or 12 control points across the image, things are looking pretty good. The residuals in the X and the Y are generally on the order of 1 to 2 meters, maybe up to 3 meters of difference from where the alignment of the imagery is at the control point. And so that's pretty good because if you consider the size of the pixels, if we zoom in on this image, it's a pretty high resolution image, but the pixel size is probably going to be on the order of near a meter. And then additionally, the control points, if we look at some of them, we're doing like the corner of a driveway and a sidewalk here. And so, that position probably has changed through time, given that this image is from the 1950s. Sidewalks might have been redone, things like that. So being off by, on average, 2 to 3 meters is probably a very good result, probably as good as we can hope for. So I feel good about that. The other thing we could zoom around and look at more of those control points. Like here is kind of just the center of the road intersection. And here it's now a traffic circle. So how good can you do? But what you really want to see is is the overall fit good away from the control points too? And if we turn off and on these roads, you can see it's nicely aligned between the old and the current roads. And so it seems like a good result. So at this point, it's probably a good stopping point using this second order polynomial. If we go back to the first order polynomial, we can see things get warped a little different. The residuals go up, and the image is kind of more rectangular because it doesn't have as much dimensions of change. And so that second order polynomial is probably the sweet spot, matching up our residuals. We could make the residuals even less, probably by moving to a third order polynomial, but it's actually going to probably make the areas away from the control points look bad. Let's see that. So you can see we got some distortion down here. We only have this one control point. And there we can see the roads might be off quite a bit. So generally speaking, unless you're able to put a lot of control points throughout your image, you kind of want to stick to no higher than a second order polynomial, which is going to help to correct for like lens distortion from the camera, from the air. So that should be pretty good. So we can see we can get kind of a report about our georeferencing, which is kind of a metadata, a bit of metadata. So if I generate that report, we can see what that looks like. I'll just save that briefly and see what it looks like. So it shows us how many control points, the amount of residuals, and their location in space. So in theory, you could like show exactly where those control points were as well, which is maybe good enough, right? You could also take a screen cap and add that to a report to show where your control points were located as well. That would be a nice bit of metadata information to store. Also, you'd want to say what coordinate system this has been georeferenced to, which is NAD 83 UTM zone 12 north. And so that's great. You can export your control points if you wanted to preserve them, or we can also just save our georeferencing. And that's what I'm going to do here. So once the georeferencing's been saved, I can close georeferencing and the data is now georeferenced. If we were to go back to where it's located in space, in the folders, we would see that there's now a world file associated with it, meaning that it is a geospatial data set. And so that we'd want to add a metadata file in there the folder where we're storing that. Okay. And so, you could go back to the original file and move it. Another way to go would be to export the raster into wherever you're working and save it there. If you do that, you always want to be careful that you're doing it correctly. Make sure you can see the coordinate system is correct. We're in the right type of pixels, which is 8-bit because it's an image. That would work. Okay, so that's kind of describing saving your metadata and finalizing your georeferencing by just saving it. There was also an option to save as a new file. And that's another good way to go if you are not sure you're happy with the georeferencing result. You could save the georeferenced image as a separate file and keep the original unreferenced image. I didn't opt for that here. Okay, so the next step will be looking at land cover change through time and mapping that. And so we'll stop this video here.